Welcome back. This is Chapter 4, Video 4, in which we'll encounter the rules viii, Introduction, and Elimination. Here we have one of the simpler rules in viii, Introduction, and one of the more complicated rules in viii, Elimination. I'll talk about them briefly and then illustrate with some examples. First of all, if we focus at the top here on viii, Introduction, we can see what this rule is telling us is that if at some point in a derivation we have the formula p, then from that formula we can derive a disjunction of it with any q, putting q on the right-hand side to get p or q, or putting q on the left-hand side to get q or p. This q can come from anywhere. It doesn't have to already be a part of the derivation. It can be just about anything you want. We'll discuss the reason for this in just a minute. Now a preview of or elimination. This is one of the more complicated rules because it requires three pieces: a disjunction and two subderivations. Basically what this rule tells you is if you have the disjunction p or q, and then with two separate subderivations you can show that p leads to some element r and q also leads to the same element r, then those three pieces together get you to that formula r. And then we would cite the original disjunction and the two subderivations. We'll come back to this in a few minutes and talk about it at length. Let's take a closer look now at viii, Introduction, or as I often call it, or introduction. Consider the following argument. If either Ann or Bob goes to the fair, then Carol will go. Ann goes to the fair. Now the obvious conclusion to draw is that Carol will go. But of course, if we're being super strict and technical about this, we can't draw that conclusion. Why? Well, notice that premise 2 does not exactly match the antecedent of premise 1. They're not the same. But it's pretty obvious that we should be able to get from 1 and 2 to the conclusion. Our rule, viii, Introduction, or introduction, helps us to see how this works. Consider this. Since 2 tells us that Ann goes to the fair, then we know that Ann goes to the fair or fill in the blank with anything you want. In this case, we want to fill in the blank with Bob goes to the fair. What we get is a third premise where we take Ann goes to the fair from premise 2 and we just stick Bob goes to the fair onto it with an or. Now if we want to condense that a little bit into more colloquial English, we can change it to Ann or Bob goes to the fair. So now we see 3 does exactly match the antecedent of line 1. So from line 1 and 3, we can get to our conclusion, Carol goes to the fair. Formally, this will look as follows. We can symbolize premise 1 as A or B, then C, mark it as a primary assumption. Line 2 would be A, also a primary assumption, and the goal of our derivation here would be to get C. Now I'm sure you can see what we're going to want to do is an arrow elimination, a conditional elimination in order to get C, which is sitting right here. But in order to do that, we need something exactly matching the antecedent, and we do not have that in line 2. But our OR introduction rule will allow us to do it very simply. All we need to do is take line 2 and stick OR B onto it, and we can cite line 2 OR introduction. Now obviously line 3 exactly matches the antecedent of line 1. So we can use 1 and 3 together to get C from line 4 by arrow elimination. And in fact, that's generally going to be the context in which you use OR introduction. When you need a disjunction and you already have one of the pieces, you can just create that disjunction. For example, let's take a look at a simple little derivation for the sake of illustration. We'll start with one primary assumption, the letter D. And what I want to derive is something like that. Well, I don't have A or B, or A and B, in my primary assumptions, but I do have the D. And since I have OR introduction, just having the D will allow me to get to my goal very easily. A simple OR introduction. I'll take the letter D and stick onto it with the OR the A and B, and I would call that one OR introduction. Now, let's forget about this particular goal for a minute and see what else we can do. I can go from 1 to D or G. I could go from 3 to... In fact, as long as I've got something, I can stick anything I want to onto it with the OR on either the right-hand side or the left-hand side. Now here is a mistake you definitely want to try to avoid. Don't confuse OR introduction with AND introduction. What I mean by this is I don't want you to make the following mistake. Suppose we had G as our primary assumption, and I'm not concerned with any particular goal here. You might think you could go to B and G from 1 by AND introduction, because it sort of looks like what's going on over here. But this is a big mistake. In order to do an AND introduction, we would need to have G and B separately, but here we don't have the B. What we could do in line 2 instead is go to B or G, and that would be a correct application of one OR introduction. So just make sure you don't confuse these two. To do AND introduction, you need both pieces. To do OR introduction, you need only one piece. And in this case we have the G, so we bring that down and we stick onto it B OR. We could of course have done this as well. And of course the B here could be anything simple or complex. Now let's take a closer look at OR elimination. This rule is a little bit tricky because it's rather complicated, but I think you'll find with a little bit of practice it makes perfect sense. First off, let's look at the form of the rule. What it's telling us is if you have a disjunction, P or Q, then if you can do two subderivations, one starting with the left disjunct P and leading to some possibly distinct result R, and the other starting with the right disjunct Q and also leading to that same result R, then those three things together will give you the R. The idea here is that the disjunctive formula is telling us that at least one of two things is true, P or Q. If we can show that both P and Q independently lead to the same place, the R, then we know that P or Q, P leads to R, Q leads to R, will give us the R. Let me demonstrate with an English language example. Consider the argument on the right. If Carol goes to the fair, then Ann will drive. If Bob goes to the fair, then he will pay for gas. If Bob pays for gas, then Ann will drive. Either Carol or Bob goes to the fair. And remember, we're considering that an inclusive or, so it might be both. 1 through 4 actually imply that Ann will drive, but it might not be immediately obvious how that happens. Let's see how it goes. First, notice that if premise 4 were a conjunction instead of a disjunction, that is, if premise 4 instead of having an or had an and, this would be a very short deduction. From 4, we could get Carol goes to the fair, and then from 1 and 5, we could get our conclusion. Then from 1 and 5, we could get our conclusion, Ann will drive. Which would basically be a conjunction elimination and then an arrow elimination. But that's not the situation we have. We don't know if it's Carol that goes to the fair, or Bob that goes to the fair, or both. But we can still reason in the following fashion. First, let's suppose Carol goes. That'll be an assumption. Now, if that's the case, and note that I've indented it to indicate that it's an assumption. If we suppose that Carol goes, then 1 and 5 will get us Ann will drive. Now, hold that thought for a moment, and let's suppose separately that Bob goes. Again, indenting. Right. Well, 2 and 7 tells us that if Bob goes to the fair, he'll pay for gas. So together with 7, that gets us. But of course, 3 tells us that if Bob pays for gas, then Ann will drive. So 3 and 8 together get us Ann will drive. Now, we still don't exactly know that Ann will drive, because that assertion in 9 depends on the assumption in 7 that Bob goes, and Ann will drive in 6 depends on the assumption in 5 that Carol goes. But 4 tells us that one or both of those things are happening. So 4, together with 5 through 6 and 7 through 9, get us that Ann will drive. That is, we can write line 10, not indenting, Ann will drive, Ann will drive, and that comes from 4, 5 through 6, 7 through 9. Now let's see how the corresponding derivation would go symbolically. If we symbolize the premises as primary assumptions, we get C arrow D for Ann will drive, B arrow P for Bob pays for gas. The third one would go to P for if Bob pays for gas, then Ann will drive. And the fourth primary assumption will be C or B. And our goal here, of course, is to get to D, Ann will drive. Now again, notice If this were a conjunction, we would be home free. We could use conjunction elimination to get either C or get B, and then with one or two arrow eliminations, we could get quickly to D. But it is not a conjunction, it's a disjunction, so we're going to have to use the disjunction elimination rule. In order to get to D with disjunction elimination, let's see if we can treat D as the R position and C and B in the P and Q position. It's pretty straightforward. We'll follow the pattern we used on the right-hand side in English. So in line 5, we'll make the assumption that Carol goes to the fair, or we'll assume C, which is the left-hand side of the disjunction 4. And that immediately allows us to derive D from 1 and 5, arrow elimination. Now we let that subderivation just sit for a minute and we start a new one at the same level. This time we're going to assume the other disjunct as our auxiliary assumption. So we'll assume B, mark it as an auxiliary assumption. And then with 2 and 7, we can get P by arrow elimination. And then 3 and 8 give us D, also by arrow elimination. And now what we have is a situation where we've got a disjunction. We've shown that the left disjunct leads to D, and we've shown that the right disjunct leads to D. So those three pieces together, line 4, subderivation 5 through 6, subderivation 7 through 9, give us the D. So we write line 10, and we cite all three of those pieces, the disjunction 4, subderivation 5 through 6, and 7 through 9, or elimination. One thing worth pointing out here is that unlike the other elimination rules, it's entirely possible that you end up with a result that isn't in the original OR statement. With AND elimination, you wind up with one or the other of the conjuncts. With arrow elimination, you wind up with a consequent of the arrow statement. With hook elimination, you wind up with a thing that had the hook on it. Here, OR elimination very often winds up with a third element altogether. In the immediately previous derivation, we had C or B, but the OR elimination gives us a D. This isn't necessarily always the case, however. Sometimes you wind up with one side of the original disjunction. We'll see some examples of that later on. Here's an example where OR elimination doesn't give us a third element. It'll be a case where the P in the original disjunction is the same formula as the R in our result. So consider the following simple derivation. Our first primary assumption will be E or F. Our second primary assumption will be if F, then B and E. And our goal here is just to get to E. Now obviously, if 1 was a conjunction, we could get E out of it straight away, but it's disjunction. Frequently, when you see a disjunction, an OR statement, like line 1 here, you're going to have to use OR elimination to cope with it. Right now, there's just no other way around it. But if our goal is E, we can see pretty quickly that we can do one of the subderivations by assuming E and immediately reiterating E. What good is that? Well, it shows that the left-hand side of line 1 leads to E. And we can do it very simply because it's just an obvious reiteration. Now we need to show that the right-hand side of line 1 can be made to lead to E. So we start a new subderivation. We assume the right-hand side of the disjunction in line 1, and we need to show that that F leads to E. Now obviously with line 2 and an arrow elimination, we get B and E, and then one more step, a simple conjunction elimination gives us the E from 6. Now, we've got E or F. E obviously leads to E, and we've just shown that F, with the help of line 2 and a conjunction elimination, leads to E. So all three of those together lead to E. And we can write that in as line 8, 1, 3 through 4, 5 through 7, or elimination. And there's a case where the result of the or elimination is one of the original disjuncts. As we saw earlier, that sometimes isn't the case. P, Q, and R are sometimes 3 different formulas. But sometimes, as in this one, it is the case. In this case, R and P are the same formula, but it could be the case that Q and R are the same formula. It could even be the case that P, Q, and R are all 3 the same formula. So those are the basics of the V introduction and V elimination rules, also known as OR introduction and OR elimination.